I didn't
Really?
I can.
So I don't.
Just want to make sure.
The back.
That was admittedly not our PI's fault.
I mean,
Does not.
do you have any?
Remember how long ago, I guess you were.
Oh, I can get out of.
Are you going to introduce?
Yeah, I'm going to introduce. So welcome everybody to this very special final TWed of the spring 2026 season. Thank you all for being here. Today we've got a very special guest. I'll let Deborah introduce him. Excellent.
Yeah, so we're really excited to have Ora Lassila join us today. Ora is a longtime friend of many of us, but longer for both Jim and me, decades actually. I think each of us met him in the 90s. So he's got many claims to fame, but one of them, of course, is as a co-author of the famous Scientific American Semantic Web article with Jim and Tim Berners-Lee that on May 17th will have 25 years of publication.
Is that the day?
Yes, I looked.
Well, that's actually when it released publicly, so it's the May issue. And so if you were a subscriber, you got it a week earlier.
Yeah, well, okay. I looked it up on the web for the date, and May 17th is the date. But okay.
Doesn't matter.
But we can have the provenance of that encoded in prov. And Ora has a long, wonderful history, but many of his contributions are around things like RDF, and he's co-chair. Yeah,
Yes,
co-chair
co-chair.
of the RDF working group, RDF 1.2 working group, and we'll get an update.
Yep, thanks, Deb. Thanks for coming to my talk. Let me just give a brief introduction beyond what Deb said. So I've recently joined Accenture, and so if you have, this is like I think my 4th day of work, or well, technically my 3rd real work day at Accenture. So if you have questions about Accenture, I'm sorry, I can't answer that.
Oh.
I don't know, because I don't know anything.
Can I add something? So Sabir, who graduated from this group, is in the same group as Ora at Accenture. So
Yep.
very excited.
And in fact, I was attending my first group meeting today, earlier today, and met him. So it was good. So good. Okay, so let's. If only I could get this. Right. So I was earlier. I was at AWS, where I was a member of the Neptune graph database team, and I've been working at many places. I spent many years at Nokia, which used to be a little company that made phones, 40% of the world's mobile phones or something like that. I was at Nokia Research most of that time, and I also spent a few years at MIT and several years at Carnegie Mellon. I immigrated here from Finland a long time ago. So I was the co-author of the original RDF specification. Basically, what happened is that I was one day, I think in '96, I was in my office at MIT minding my own business, unsuspecting what would happen. And Tim Berners-Lee comes into my office and says, "So, what is wrong with the web?" And I'm like, "Well, Tim, I'd like to build agents that go out there and do stuff for me and use the web as sort of the platform and the source of information and things like that. But I can't do that because you built the web for humans." And he gets very excited and he's like, "Yes, that's it. That is what's wrong with the web. How do we fix that?" I'm like, "Well, you know, we have to feed the agents with something they can actually consume. So could we try knowledge representation, ontologies, stuff like that?" And he's like, yeah, we could do that. So he leaves, he turns around at the door, points at me and says, "Okay, Ora, now you do it." And that's basically all I have been doing ever since.
So just so you know, the way our group got into doing open government data at one point was Tim and I had been at a meeting with the CIO of the United States. I was there mostly because Tim invited me, and Danny Weitzner, another friend of ours. And he's saying, he had seen what they were doing.
Sorry.
He saw what was happening. He saw what was happening over in England, right? And, said, can we do something like that? Do we have a group of people who can take government data and put it together and turn it into demos? And Tim said, of course. And then we walked out of the room. Tim said to me as we got ready to walk down the stairs, by the way, Jim, that's you and your group. You're doing this now. So we became the open data group, and then I moved to RPI. So RPI became very well known for government open data. Because of that same kind of thing. Sorry. Just talk, not much.
Okay, so I've done a whole bunch of this RDF and semantic web stuff, but earlier I did write some knowledge representation software that flew on the NASA Deep Space One probe that reached the asteroid belt in the late 1990s, which I thought was pretty cool. It was actually the knowledge representation substrate for a automated planner and an agent that basically ran the spacecraft. It was an experiment. NASA let the people who wrote the agent to run the spacecraft for a while. And I guess what actually happened is that something went wrong with the spacecraft, not with the planner. Some component malfunctioned or something like that. And the planner reactively sort of planned the operations of the spacecraft to kind of make it so that it didn't matter that one component was malfunctioning. So it did exactly what it was supposed to do. So I wrote the knowledge representation component for that, and my fondest my threads for as a software person is that when I was in grad school, I won the grand prize of the code contest. That's me. So
what did you write for? What did you write that won you that?
So the program, which is to 1,536 characters, a kilobyte and a half, was a Lisp interpreter. and it basically executed Lisp expressions by basically directly interpreting the textual representation. It never actually did what all Lisp implementations do, is which they parse textual representation into the linked list structure. It never did any of that. It's just, and it basically figured, you can malloc forever. So, it never did any garbage collection or anything like that. It just kept like allocating more memory and it did basically like string searches, to find, if you did like a cutter on a list, it just, found the opening paren and then, skip over the first element or whatever. And so that was possible to get into a small size like that. But the most annoying thing is that for years afterwards, I kept getting emails from people who wanted like, hey, I'm working to extend your Lisp. It's a spoof.
Contrast that with your OMG win
Oh, my,
experience.
oh, my, yeah, oh, yeah, well, right. So Deb wants me to mention that last summer, OMG ran a competition, semantic augmentation challenge, which basically they were interested in how to go from various kinds of legacy data to knowledge graphs. And the basic ask was, here's a CSV file of some financial data. How would you turn this into a knowledge graph? And first I thought, I'm not going to participate. But then 2 days before the deadline, I thought, well, this is kind of what I do, so maybe I should do it. And I basically wrote a very small ontology, a very small RML mapping, and about 40 lines of Python to orchestrate this and turn it into a knowledge graph. The ontology was basically an extension of FIBO and or used terminology from FIBO. And it took me, I don't know, an hour, 2 hours maybe to write the whole thing. And I sent it in, and then a couple of weeks later, I get this email saying, congratulations, you made the 5 finalists. And like, now you have to prepare a presentation to tell people what you've done. And it took me literally longer to write the PowerPoint presentation than it took me to write the actual solution. And it was only supposed to be a 10-minute PowerPoint presentation. So then I go and I give this presentation, and there are 4 other finalists who, all these was very extensive work, like so much effort went into obviously doing all those things. And my whole argument was that, or sort of the case I wanted to make, is that this is not rocket science. All the technology, all the standards, all the software, it all exists. The only thing that's missing is that people don't know how to do this, and we have to tell them how to do it. And here's a really simple example how to do it, and it solves the problem.
Pizza's in the back room, guys.
And then after deliberating, the jury announced that I won, which was a little bit embarrassing because it took so little effort. But on the other hand, this is not rocket science. Now, of course, since I mentioned the Deep Space One, even if it was rocket science, would not be a problem, because usually I am a rocket scientist. So, yeah. They promised $1,000 as the grand prize. They still haven't paid, so I'm not holding my breath. But OMG, I think is kind of
Also true of the honorarium.
yeah.
I said, you're getting an honorarium.
All right, so let's talk about RDF a little bit. So RDF, as you all know, is a simple knowledge representation language and very widely adopted and deployed. So I don't know what the exact percentage is today, but certainly more than half of all the web pages out there contain some form of embedded RDF. All Adobe documents contain some RDF. When I take a lot of photographs, when they go through the Adobe toolchain, they end up with an RDF graph that's somewhere between 100 and 200 triples. And this is a quote from a close former colleague of mine, which I really like, that RDF has turned out to be the most catastrophically successful failure there is. A lot of people told us that RDF is just not enough, or that it's just, we don't know what we're doing, and
Do XML instead, or that we should do XML instead.
right, or yeah, all kinds of stuff. And it turns out that the way I sort of look at it, the RDF is the most successful attempt to get knowledge representation out of research into the real world. So that's basically RDF. It's been around for a long time. So here's the timeline. After my unfortunate encounter with Tim Berners-Lee, MIT, I started working on some stuff, and I looked at this thing called PIX, which was a W3C specification for content filtering. And I looked at it and said, this looks a lot like a very simple knowledge representation language. So what if I extended that to be more general, so it wouldn't be limited to content filtering anymore? And I wrote a proposal for that. October over there. That's a typo. So basically, we then found other people who had been thinking about similar kinds of stuff, simple knowledge representation in the web context, and we got people together, had a workshop, decided we could actually have a group that works on this thing, and then eventually we named it RDF. And October '97 was when we published the first public working draft of what eventually became the RDF specification. And then
Was MCF? When was MCF?
MCF was around the same time.
In about 95.
Yeah, 95.
And when was Shoe?
What?
When was Shoe?
Well, our first published paper on shoe was 96.
Right.
So it was right around, I mean, it was a little bit.
I mean, that time, I think the time was just right for that,
No, I'm just curious because that was the failed version that had gone through the standards. Wasn't that W3C or was that IEEE?
Not W3C, I don't think.
Yeah,
I reviewed it.
Guha did it.
I got a draft just from Guha when I was at Bell Labs.
No, I know. But I'm saying, but I know it was Never mind.
Well,
I don't know.
there were a lot of people who had been thinking about similar.
Sorry.
Yeah, well, there were a lot of people who had been thinking about similar kinds of things, and we just had to get some momentum on it. And then in February 99, it became what W3C calls a recommendation, which is the W3C term for their kind of official standard specification. And then 5 years later, we revised that, and that became then actually the RDF 1.0. Then Sparkle came along. The first Sparkle was a disaster. I had this discussion. I wasn't participating in the Sparkle work, but I frequently talked with the people who were working on Sparkle, and I told them at some point that you have to have some kind of support for paths. You know, you want to follow paths through the graph, and this is what they told me, and I'll quote them verbatim. They said, paths are not a use case for graphs.
Oh,
And I called them, at that point, I called them idiots. Actually, I used a much stronger term than that. Might have involved the F word. Because that's just cluelessness.
I worked with some of those initial people at HP Labs in Bristol.
Yeah,
I know some of the people that.
yeah, right.
Don't say their names.
And I told them that paths are the only use case for graphs, really. Sparkle 1.1 was improved thing. You could actually modify the contents of your database with the Sparkle 1.1, and then it had some support for paths, so that was good. And then RDF 1.1, another revision came along in 2014. Now, RDF always had this the reification mechanism, which would let you basically say things about the things that you've said. So statements about statements, if you will. It was always kind of like a misunderstood and not well appreciated feature of RDF. I say misunderstood because people always thought that they had to fully materialize what the reifications, which of course isn't necessary. But there was some attempts to kind of fix reification, and finally in 2021, the community group at W3C published their final report on how to fix that, and then in the aftermath of that, we started the actual working group that can produce a real specification. And it used to be called the RDF Star Working Group. It's now called the RDF and Sparkle Working Group. And just a few weeks ago, we first two specifications went into what W3C calls the candidate recommendation stage, which means that we are now looking for, we are now done through all the internal reviews at W3C. And we're now looking for implementation experience. And there is a whole bunch of other specifications that are about to go to candidate recommendation stage. We have more than 20 documents because we basically had to update all RDF and all Sparkle documents, plus produce a few more just to tell people how to achieve interoperability with the older versions.
Before you leave that slide, so we had Greg Williams.
Yep.
Was
Greg, right.
on Sparkle 1.1, right?
Yeah, and Greg, actually, my former colleague at AWS, has also been participating in this RDF 1.2 work.
Excellent. And then Tim Lebo was on RDF 1.1, right?
no, he was on Bravo.
He was on Bravo. I thought we had a student on RDF.
No,
Greg was, when I was 6 years, was at AWS, he was really my go-to person for any questions that I couldn't figure out about Sparkle.
Well, when he was here.
More about
That was the same thing.
He was our go-to person.
We really were upset when he left.
Yes, of course.
he was still our go-to person.
He literally knows everything about Sparkle. So
Truth beer too. At least he used to.
he doesn't talk very much, but you know, he answers questions, so that's good. Okay, so yeah, so statements about statements. So the reification mechanism essentially allows you to do this by kind of modeling RDF statements in RDF itself, and And this reification being kind of cumbersome has been one of the most persistent criticism of RDF. The funny thing is that if you look at the draft versions of the original RDF model and syntax specification, reification starts out pretty close to the top of the specification, the top of the document. And in consecutive versions, it keeps moving further and further down until in the published version, it's at the very end. We also had this interesting thing in the original working group. At some point, I pointed out that we need a semantic theory for some kind of semantic theory for reification. And people are like, well, yeah, okay. And then I said, you realize that we may have to step into some system of modal logic to do this. And as soon as I said that, nobody wanted to touch it. So that's why reification never had any kind of semantic theory. Reification could also be seen as sort of the RDF counterpart of edge properties of labeled property graphs. So, but there have been many ideas over the years how to fix reification. And I think the most notable attempt was this paper written by two of my AWS colleagues called Reification Done Right, which then basically inspired the formation of the RDF star work, which is now the working group doing this RDF 1.2.
So Olaf was, he was a guest scholar here for a while, Olaf Hartig.
Yeah, and he's now an Amazon scholar, so he's still a professor at University of Linköping in Sweden. So basically, here's a triple. A relates to B via the property P. So what do you do if you have to say some things about this relationship? So the standard reification looks like that. If you read turtle syntax. But many people basically just kind of lift the relationship to be its own node. And they do something like here at the bottom, which is effectively the same as doing reification. So that's a typical RDF kind of modeling vehicle. Use cases we basically figured that are important for this work that we're doing now is that people want ways to express provenance. They want to have qualifying statements. They want to annotate things, and possibly people will want to do some type of modalities, beliefs or whatnot. And then, of course, there's this whole question of what we often call RDF LPG alignment, which when I was at AWS was important for our group, AWS, but there were a lot of things that were kind of controversial, and there are many members of the WCC working group who don't really see that as much of a priority. So, but I think that this is going to move RDF and LPG kind of closer together. So it should be seen as a good thing. So we have some challenges. So RDF graphs have basically set semantics when it comes to triples. So triples are unique. So we can say that Elizabeth married Richard, but what if we want to qualify this with a year? Well, that's fine if they only get married once, but what if Elizabeth divorces Richard and then marries him again later? How do you do that? Now you need basically two triples, but you can only have one. We absolutely did not want to break the existing RDF semantics. There's 30 years of work that people have put into systems that use RDF. You can't go and mess with things. And also, if you break RDF, you might break OWL too. And Deb would be very unhappy. Some other people too. And then, of course, there's the whole question to be clarified is like, what is the relationship between statements and named graphs? So what if you have a named graph that only has one triple in it, and you say something about the named graph? Have you now said something about the statement? Or, of course, named graphs also have no semantic theory, mind you, and we did not touch name graphs mainly because name graphs have kind of developed this. People have used them for many different purposes, and there's kind of like semantics by convention, if you will. And we didn't want to usurp any of that by saying you can only use it for this. So we left name graphs alone, and didn't touch them in this work. So the basic idea of how this extension now works is that we add one more term type to RDF. So the existing term types are IRIs, blank nodes, and literals, right? And so we add fourth one, which we call triple term. Triple term behaves a lot like a literal. You can think of it almost like an unasserted triple. You can imagine that you could match it against triples that are already in the graph. And using a relationship called reifies, RDF reifies, we can associate some identifier with the triple term. So we can take either an IRI or a blank node, and we can say that it reifies some triple term. And triple terms can only appear in the object position of a triple, just like literals. So we could say something like this, that the identifier marriage 1 reifies this triple term that says Elizabeth Taylor married Richard Burton. And now marriage 1 would be an occurrence of the original triple. And then we could have other identifiers that those would be other occurrences. And that way we could solve that problem with the multiple marriages, for example. So the RDF 1.1 model theory has been extended just so that it covers the additions that the new version introduces, and it has been done very carefully so that we can still have kind of OWL layered or constructed over the RDF 1.2 semantics without breaking anything. So that was like very important. We also extended. We didn't only touch reification. We also added a new data type for string literals that have an initial direction of the text, which use it now combined with some Unicode tricks. We can now have literals that have mixed direction. So you can have Arabic text followed by some Western text in the same literal. And the syntax we extended basically all the RDF serialization formats had to be touched. And the triple terms look like I've shown here. And we also offer some syntactic sugar, kind of like syntactic shorthand, for making it easier to use these triple terms. If you don't use the triple terms, the syntax, all the syntaxes are exactly the same as they were with RDF 1.1, except of course with the literals, the bidirectional literals.
Sounds to me like intentions and extensions in Montague logic, right? Why this only occurred now or 2000 whatever 14 that we need that?
Well, I wish I could answer that
Yeah.
question, because we would be way ahead of the game now. If I had been able to answer any of this, particularly why didn't we do this earlier? We tried to do some of this way earlier during the original RDF work, but at some point we just needed to get the specification out the door, and some things just never happened. I mean, it's Pat Hayes told me, I think it was last year, he said that when he first looked at RDF, he thought it's a lousy knowledge representation language. Then he says, and he didn't understand that Aura wanted it that way. And because it has to be a sort of a low barrier of entry. It has to be something simple on top of which something more complex can be built. But, you know, OWL is the more complex thing that got.
But that's been the case with everything. You know, the SGML people thought that HTML sucked.
Yeah.
You know,
An OWL stopped short of some number of expressive constructors that we knew how to do because we had to get it out.
I could make some comment now about the academic community, but I will not. So, because yes, there are things that we would have wanted, definitely for OWL, and there are things we would have wanted for RDF. But on the other hand, we also wanted to get it out the door and get people to use it and start building other stuff for the semantic web. The thing with the semantic web is that, yeah, you could do all that by yourself. You could invent all of the stuff. But semantic web is a team sport. It doesn't really make much sense to play alone. You have to have other people play too, and then it makes a lot of sense because it's about interoperability and exchange of things and whatnot. And so we needed some basic ground rules, and RDF is the first step to introduce some basic ground rules for this so that all this other stuff could be built. And thus it's a very, actually I working on the original RDF specification, I get this email from Pat Hayes. So those of you who don't know, Pat Hayes is a super famous knowledge representation and logic person, former president of AAAI.
Shortest email Pat has ever written, I think, was about 42 pages.
Yeah, so he also has no filter. He's very honest in things that he says back. So, and he really knows his shit.
And great for model theory. So he's worked on RDF model theory, OWL model theory.
Yes, he
UL model theory.
that's right. So I get an email from him, circa 1998, that says he's looked into the RDF work, and it is clear to him that we don't understand, we have not read even the elementary textbook of logic, let alone elementary textbook of knowledge representation, and that all work should be discontinued immediately. And I was a little taken aback by this because I knew who he was. I didn't know him, but I knew who he was, so I wrote this overtly polite email back explaining what it is that we're doing, and I used the expression, this is going to be a small step towards something bigger. Plus a lot of explanation on what we're doing. Get an email back saying, oh, so now he understands you have read the elementary textbook of logic and the elementary textbook of knowledge representation, and therefore he now considers gloves to be off. Like the first email wasn't that yet, where he said everything should be discontinued immediately. And I basically forwarded the email to somebody who I know Pat had been on this person's dissertation committee, and I said, you handle this. But then when RDF 1.0 work started some years later, I told Eric Miller, who was the head of the semantic web activities at W3C, I said, I want Pat Hayes as an invited expert. And Eric looks at me like, are you really taking some strong drugs? Like, what? I said, no, I definitely want him in the camp pissing out rather than outside the camp pissing in. And Eric said, it's never going to happen. And then at the time I was Nokia's official representative to W3C, among other things. And I basically told Eric that I'm pulling all the resources that Nokia is putting to W3C, including all the effort on the semantic web, unless I get Pat Hayes in the working group. Of course, I was bluffing, but Eric didn't know that. So we get Pat, and Pat is a good model theory person, and his most important contribution for RDF really is that he wrote the model theoretical semantics for RDF. And then one day we're in a working group conference call, and Pat gets all excited about, about things. And he says, yeah, this RDF, it's a really great thing. It's like a small step towards something bigger. I'm like, why did it take 5 years? I told you 5 years ago, but we're really good friends now, and we laugh about this a lot every now and then.
The best thing about that, from my point of view, is because he'd already been accepted as an expert, member.
Invited expert.
Invited expert. He was allowed to be an invited expert for OWL. And thank God, because otherwise Peter Patel Schneider and Ian Horrocks would have defined the top of the language. And it took Pat, who could outrank them in a sense, to explain to the working group that no, there were logics that were more interesting. So,
Yeah, I got a question about it. So we've been hearing for more than a year that Jason LD is being worked on, that RDF 1.2. Is anything actually happening with that?
I honestly don't know exactly what is happening, because last September, Greg Kellogg, who was really the driving force behind Jason LD and also a member of this RDF working group, he passed away after an illness. And it was a real blow. I mean, we actually did not know what to do in the working group after he had his hands, his fingers were everywhere in that work. So I don't know what's going on with Jason LD, but I can find out. I should anyway.
or see if you can get it back. So that get it back so it can be part of 1.2.1.
Well, I mean, it would have been a separate effort anyway, separate working group. So what they're going to do is really not under our control. We just hope that they pick up the.
It's such a pity, because Jason LD has been such a great serialization format.
Sure. Yeah.
Well, so somebody should do it, Jason. The
I mean, I like Jason LD because of the
RDF 1.2 map.
Yeah,
That should be trivial.
the context.
Context.
Where you can interpret legacy JSON as if it was RDF. I really like that idea. But originally I thought that JSON LD is a little bit like RDF XML. JSON is the new XML, only worse. And XML wasn't that great to begin with.
RDF JSON was really bad because it's nothing more than XML.
Right.
But JSON LD.
Yeah, I know. Yeah, that's right. Yep. Okay, so the reification syntax, the syntactic sugar looks like this. So if I want to say Elizabeth married Richard, and I want to name that to be the marriage one, I can say, I can give it other properties then. And the syntactic sugar here at the top, it expands into these two triples down here. It's important to understand that the triple Elizabeth married Richard has not been asserted in the graph at this point. You have to assert it separately. So when we say not asserted, we mean it's not part of the graph that gets generated from this. So the annotation syntax, which looks like this, actually also asserts the original triple. So this, I think that this is going to be something we're going to see a lot. And so here at the bottom are the three triples that basically result from that one line at the top. So then there's the question of the triple occurrences. So the earlier problem about Elizabeth marrying Richard twice, here's the thing, we assert the original triple once, and then we annotate two occurrences of that triple separately. And you of course could also play with the annotation syntax to do this, but this is how it's generally done. So the question is, what's happening now in the working group? So all the big problems have been solved and settled, and we leave some issues to the next working group. Basically, the question about name graphs, I think, is something that will come up. We decided not to touch that. one of the things we had to do is that we had a lot of older documents that they weren't up to they didn't use the current W3C document toolchain. So we basically had to like bring them up to that standard. And that's grunt work that nobody actually ever sees, but it had to be done. It was a lot of work because we have more than 20 documents. So we now have two documents, basically a document called Concepts and Abstract Syntax, and then the document called Semantics. Those are now in the candidate recommendation stage, and N triples is going to be any day now. We had to sort some stuff out with the technical architecture group of W3C. They were unhappy about something, so we told them not to be unhappy, and now I think it's going to be okay. And so the so-called horizontal reviews are completed there, and we're looking for kind of implementation experience now. To move to the last stage of the process, we need 2 independent implementations.
2, 3.
I think it's now 2.
Okay.
And we kind of have this idea that we proceed in these waves. So we take a small group of specifications and we move that forward, and then we work on the next one and move them forward. Dependent documents can only be one step apart in this process. So we have to have like the final public draft, working draft or something like that. That's like the one stage. Then the candidate recommendation is the next stage. Then we have the proposed recommendation. So we cannot, if 2 documents are depending on one another, one cannot be proposed recommendation. The other one can't be the last public working draft. They have to be only one step apart in this process.
So something like RDF 1.2, what is considered an implementation?
Well, we have a test suite.
Okay.
Yeah, and so you can make an implementation and you can say, these are the results when I ran the test suite.
But I still,
Question, doesn't include stuff count this.
It is actually, well, we can actually, there's a longer conversation to be had, but there's actually ways to support this without implementing triple terms. That we have this kind of a sort of a subset, we call it a profile, where you can basically be RDF 1.2 without having to support the triple term mechanism. And we're hoping nobody does that, but
well, I guess what I'm saying is, so does it implement, are you building a graph based on 1.2? And then you apply the test suite to that? What are we talking?
yes,
What is an implementation?
well, the test suite is basically expressed in N triples.
Yeah.
And basically, it has a series of test cases where say, oh, we assert these triples, and then you should have this in your. So given this syntax, you should get these triples in your triple store.
I see.
And it covers all aspects of the specifications. So yes.
You just invite people or they volunteer to create those implementations?
Who gets to do an implementation?
Anybody can do it. Yeah.
For Nippon's work, we are using N3.js, which the authors claim it's fully compliant with the candidate recommendation
Okay.
and passes all the test suite.
Okay. Yeah. Well,
So he might have one.
So that's what I meant.
yeah. So the Apache Jenna, I think passes the whole test suite now.
Yeah.
We haven't heard from others yet, but I know that many people are working on things. So I don't think we're going to have any kind of shortage of implementations, but all implementation reports are welcome.
And you said some issues will be more on the next working.
Mhm.
Do you see that on the horizon? Aren't you all burned out? You think-
Well, we are very burned out, but what we're going to do is that we're going to switch to what is called the living specification model. which is a lighter weight process for making modifications to the spec. And essentially, we will not disband this working group. So this working group can continue working, and then effectively it's the next working group. So we'll see. I think right now we're a little bit burned out from 3.5 years of work. This may seem like not very many changes considering 3.5 years of work, but modifying an existing standard that has many implementations and a lot of usage is not easy. You have to be very careful. And also I wanted to have all the possible conversations, kind of let all the flowers bloom, all the possible suggestions of what to do and how to modify, so that when we finally go to the recommendation stage and publish, that the next day there won't be people who say, well, didn't you even consider this? Because I can pretty confidently say, whatever you bring, we have considered it. We've had so many discussions, and then some issues were quite controversial and took a long time to resolve. So, okay, so the summary is reification was misunderstood, considered awkward. RDF is criticized for the lack of edge properties. The property graph people like to point this out. They're not strictly speaking needed, but so we simplified the reification process. We have extended syntax and semantics, and we're almost done. So that's kind of the short story, which turned out not to be so short, but
It was perfect because we talked about it now.
Questions?
yeah.
I find these tests,
Where can you find what?
the test cases.
Yeah, so go and I should have given you the URL, but you can find the working groups
Oh, yeah.
homepage at the W3C website, and all the specs have been linked. And there's a separate document basically that documents the test suite, and so you can find it.
Right.
So fundamentally, when you're testing, is it n triples coming in? Is it a interpreting that and the output being what is actually asserted? Is that ultimately what is happening?
I'm sorry, can you?
Okay, I'm trying to actually imagine what the test suite does, and you mentioned that the n triples in.
Yeah, so basically what the test suite does is that it basically, I mean, it's a test suite for the entire RDF specification, not just the extensions.
Right.
So basically whatever an RDF implementation, let's say a parser, let's say you implement an RDF parser, what it should be able to do. So this expression parses into these triples.
Yeah.
So there could be like a little fragment of tuple, and then there would be a little fragment of n triples. N triples is considered kind of the base format. And it says, if you parse this turtle, you should get these triples. And it's pretty easy to implement something that drives that. So these tests have been around for a long time. We just basically have added to the tests so that
You can see visualization of RDF 1.2.
yeah, please. I have to leave in like 15 minutes, but I of course can answer questions later via email or whatever. So if anybody has more questions.
Let me,
So basically, you are looking at the W3.
want to show the input? Can you show the?
Oh, yes, yeah.
I mean, we can figure out what it is. And I think these are examples that are from.
Yes, this is
the
a example from This is RDF 1.2
So,
example.
yeah, so the examples are taken from examples in the recommendation.
With a syntactic sugar intact, and it will render.
Wait, before you go.
Oh, my bad. Let me come back. Okay, go ahead, John.
So I just was pointing out what you were saying, because there's that semantic sugar expression here.
Yeah, so then this will render like, go this. So basically now,
So you implemented your own parser, or did you?
no, I'm using N3.js parser.
Okay.
Yeah, this is what Enrique was mentioning.
Okay.
Yeah, it's just like connecting a couple of tools like N3.js with Cytospace and rendering on a React Native application on a host, like client level rendering. So basically the reifications work as again a trick, as I was supposed to say. We can see now like topic of interest has reifications. One, what is the interest? So as you can see in the side, the interest is of a class of influence, and it happened on the date of 1998.
Okay.
And as same as for the claim, you can see now the claim has one outgoing edge to me, and which is basically Alice with the base URI. And now this claims creator is Alice, so that reification there. So that's how RDF reification happens. I think like John would do much better explanation than this. And what else? That's the reification. So,
Bring up another example. Don't you have?
okay, yeah, I have a lot, but okay.
We're bringing up all 5 existing RDF 1.2 examples.
Oh, okay, John. I think I have. This is the only RDF 1.2 reification and syntactic sugar-based example that I have. But let me pull up.
Have you thought about visualizing triples that have not been asserted?
Yes, Tim Berners-Lee's homepage. That's a very, very complicated thing to handle. So this is one thing that initially broke the application, and apparently, as John explained, tested most of the existing triplet weavers are failing this, mainly because of this very interesting thing. It is a relative URI. It's just again Tim Berners-Lee's definition. It defines URI to the file itself. So
This card, which is supposed to be the like the icon, the
that's why like
mothership example, breaks most parsers right now. But Nippon made it actually work. What's Jamie's parser?
And why is it breaking?
Because it has to.
so you see here the URI, the idea weaver dash idea weaver dot local dot TTL. This URI builds on the fly because in the TTL original file, it hasn't defined any source ontology on the original URI. It's just dot. That's it.
I see.
So, and like Tim has put a comment saying this is relative URI to the given file. So I kind of went with it and to build a
The sort of discussions relating to like relative URLs. My goodness, I mean, there are so many cases that are actually not particularly well defined in even the IETF specs. So we've had to do some guesswork and then decide what does the working group really think should happen if somebody writes. relative URLs, particularly involving like dot slash and things like that.
I don't know. It just feels like neat things, but it's just.
So where is Sparkle in terms of compatibility?
It's coming. It's not in this next wave, but then after that, we have basically it will be possible to query. We've added patterns to Sparkle so that the things that you can write using the syntactic sugar in your, let's say, turtle or something like that, those kinds of syntactic patterns are also available in Sparkle. So you can find you know all the annotations for this triple, you know, whatever it is you want.
Because it would seem we can't go very far if we can express, but we can't.
Well, there is still you can always express things without the syntactic sugar.
Yeah, okay.
It's just more verbose.
Right.
So that's another thing that we are looking for implementation experience, and there will be a Sparkle test suite as well, of course.
Yeah.
So yeah, so I have a sort of a pro tip for all of you. So if somebody comes to you in the future and says, "Hey, would you like to chair this new W3C working group?"
Say no.
Hard pass. It's a lot of work.
Well,
Yeah, that's-
conveniently, right now, none of them can because RPI is not a member.
No, but you could probably do it as an invited
Yeah,
expert, but you should say no.
I am an invited expert now. It's
Yeah.
sure it's not a member.
Yeah, well, and also pro tip as well, if you're asked to be an editor of one of the documents, also take a very hard look at it.
So I was,
Actually, Tim did it while he was a PhD student, and it cost him a year and a half.
I was a co-editor on the first version of DCAT.
Okay,
Yeah.
Good.
Thank God.
we thank you for your service.
Well, I think, remember that there were three of us, I think, that were co-editors, and whoever the young guy was did an amazing job. But thankfully, Phil Archer took over and did kind of the data on the web, and they kind of refactored DCAT.
Yeah,
Because the original version of DCAT was kind of, it's almost like the basic Dublin core, but for data. And
that's right.
and the follow-up to it is much more interesting. But it was like just what you were saying though before, you got to do something, right? You got to get
That's right.
something. And it was at about the same time we did the data catalog and data set thing for schema.org. We had that same thing, and Dominic DeFranzo was part of that, and the other guy, Josh, yes, Josh Shinavir. And that again, you know, that has evolved.
Right.
But it was good enough in the beginning, and NASA had already like adopted it. So I guess there's a big lesson there about good enough. And the original Dublin core was good enough. Everybody said it's not expressive enough, but
Dublin core, which is what, 15 terms,
yes,
right? 15, a vocabulary of 15
Yeah.
terms. 4 years to create.
Although the seed of it happened in Dublin, Ohio, at a meeting.
that's why it was called. Yeah, OCLC.
Yes, at OCLC, the Online Computer Library
Yep.
Center. It's in Dublin, Ohio. So, but Dublin core pulls from years and years of experience people had with library catalogs.
Oh, yes,
And
MCAT.
It's
It's not MCAT.
all kinds of
Yeah,
stuff.
yeah.
And
A lot of library experience.
yeah, and they were actually quite actively, we collaborated with quite a bit with them during the early years of RDF.
And of course, Eric Miller made that easier when he
Yes.
So we should see if there's any more questions for Aura, because I think you've got to leave
Yeah,
in
I gotta-
11 minutes.
Sort of one.
I have another one if you, so I don't know how involved with Sparkle you are. Do you have any opinions about property paths and do you happen to know if Sparkle 1.2 is considering exploring more property paths? And I'm asking this because if you Google Sparkle property paths, you get linked to a working group document, which has a very expressive property path language involving like 0 or 1 or 1.
Let me explain. So
Okay.
The short answer is no.
Okay.
The longer answer is that there is this Sparkle dev group that is technically, I guess, a community group that for years has been entertaining all kinds of ideas about how to extend Sparkle. We are only considering one thing, and I don't know if we actually will pass it on to the next working group or we'll do it, but there's something needs to be clarified about the not exists clause in Sparkle. It's kind of underspecified in the 1.1 spec. Other than that, we don't touch.
Okay.
Yeah, but I think somebody should. There's a
But at this point, Tim would point at somebody.
the thing is that the property paths, they're constants. There's no, and I would want variables. I would, and also the thing that's incomprehensible about the Sparkle spec is that you can make a query that does some path traversal. You will not be able to find out afterwards which path you took. And in the Neptune team where I worked earlier, we decided to extend OpenCipher so that we could run OpenCipher queries over RDF. Because then we could basically solve this problem without having to wait for 5 years for W3C to get that shit through.
Okay.
OpenCipher can do these and can do these things. And a lot of customers were asking, well, I have this use case and I want to make this kind of a query. And I'm like, I'm sorry, can't do it in Sparkle. And it was a big deal. So Neptune solves it by letting you run either Sparkle or OpenCipher over your RDF data.
Okay, good to know.
The interesting thing is, he cited customers of Accenture asking that question.
Of
AWS.
Neptune, yeah.
IAWS, I'm sorry. Same point.
Yeah.
Yeah, the commercial application and stuff. Well, thanks again, sir.
We're gonna try to entice them to come back more regularly.